Alright, so this is video number 16 using a sound detector board. So what we have here to start is we do have the RGB LED. We have three 100 ohm resistors, and the RGB, the red uses 13, the green uses 12, and the blue uses 11 for the output holes. And so we also have a single pole double throw switch, which uses the number 3 digital input, and we have the potentiometer, which uses the A1 analog output, and we also have the sound detector board, which uses the A0 analog output. And so the sound detector board is the only thing on this board that needs 5 volts, so we just connected it directly to there. And we also have the ground, which goes to ground. And then this whole side, this whole part of the board right here is 3.3 volts, which just powers the SPDT switch and the potentiometer. So here is the code portion, and so here we set all of our integers. These are just the input output holes that we are using, and down here we just make some integers that we can change the value of, because we didn't make them constant. So these ones can change value, which we will be doing in the code. This one, the serial begin, it makes the serial monitor so we can have serial prints, as well as these set the input, and then we set the outputs of the RGB. Then we analog read the sound, which is what the detector is picking up. Then the switch value, which is the 1 or the 0 that the SPDT switch produces. Then we also have the sensor valve, which is the potentiometer value. Then we just make a formula for delays. So our delay isn't like 1 millisecond. We just add 400 to it. So it's at least like, almost half a second. Here we have our switch valve. If it's high, then we're going to make a variable called scale, and we just map it 0 to 3. And I'm actually using a switch case for this program. I use switch case for this program to get different values. And so here we have an else if. So if the switch value is low, which is the SPDT switch is off, then we create a map from 4 to 6 instead, which that just creates, if we go down to the switch case, it just creates a different range of colors. So we have 2 different sets of ranges of colors, which I'll show you when we demonstrate the board. Here we just have all of our serial prints. It'll print out the sound, the scale, the switch value, and the sensor value, which is good for debugging if you do have any problems. So here I'll show you the code actually working, but first this is the serial monitor, and on the far left you can see the sound detector value, which is very low right now, because usually in a quiet room it's like 23, 22, 24, around there. It just bounces around. But since I'm talking, it raised a couple. Then the 0 is whichever case it is, the case that goes 1 through 6, or 0 through 6, sorry. And then the 1 is the value of the SPDT switch. So say we just flip that, the value will now be 0. And then the last value is the value of the delay, which if we change the potentiometer, the delay will increase, which is just how long a certain color light will stay on. And so how this actually works is, so currently it's producing kind of like a purple, because we have the red and the blue on at the same time. Now that's the second range of colors we have. The first range of colors is just blue, green, red, and white. So I am playing some music right into the sound detector, and you can see the colors are changing when it gets louder and softer. And so you can see the values on here are going to change depending on how loud the sound detector, the sound of the sound detector is picking up. So 0 is blue, and then if it gets louder, it's 1, which is green. and then red is going to be the second one. And also we can change the length of the time that the light is on with the potentiometer. So now we did change the value of that. Every so often it will read a new value and print a new color. So we have 1400, which is 1.4 seconds about. So now if we play it every so often, change the colors depending on how loud it gets. And if it's the same loudness, it won't change the color exactly. So now if we want to get into our second range of colors, we flip the switch, and now it's just the same range of numbers, but it's just a different set of colors. So if we play it loud, so the colors are switching. We get a 5 there, we get a 7, and so the loudness will change, and then the light will change colors there depending on the how loud it is. And as always, thanks for watching.